Good morning, students. Today I will explain you the irrational numbers. See, all the numbers which are written in the form of P upon Q, these are known as the rational numbers. Now the characteristic property of the rational number is that either it is a terminating, that is completely divisible, or it is a repeating in nature. So the point is that rational numbers, they are in the form of the P and Q, where Q is not equal to 0, and the characteristic property is that it is always terminating or repeating in nature. Now all the other numbers which are not repeating and the terminating, these are known as the irrational numbers. All the under root numbers, under root 2, under root 3, under root 5, under root 7, these are all the irrational numbers which are non-terminating and the non-repeating. Now we have to prove that under root 2 is a irrational number. See, we will try to prove under 2 as a rational number, and if I can prove under root as a rational number, it will be a rational number, otherwise it will be a irrational number. Suppose under 2 it is a rational number, it should be written in the form of P upon Q. Now on squaring both sides, 2 is equal to P square upon Q square. So P square is equal to Q square, where P is a even integer. Now take another integer like M, then P is equal to M, and you know the lemma where A is equal to dq plus R. So here M is the integral. So P square is equal to 4M square. Now P square is equal to 2Q square. Then 2Q square is equal to 4M square, or we say Q square is equal to M square, where Q is again even integral. Now we see in both the equations P square 2Q square and Q square 2M square, 2 has a common factor, and we know that these are the integrals. So we can say by contradiction method, under root 2 is an irrational number. Now there are certain properties of the irrational number. You see, irrational number, if the sum of the irrational number, the difference of the irrational number, product and the quotient of the two irrational number, they may not be irrational number. For example, if we take under root 3 under root 3, sum under root 3 plus minus under root 3, sum is 0, that is a rational number. And if we add under root 3 plus under root 2, that is a irrational number. Now again we subtract under root 2 and under root 2, that is 0, that is a rational number. And if we add under root 2 plus under root 2, it is 2 under root 2, irrational number. And if you multiply the two irrational numbers, suppose it is under 3 and under 3, it is 3, it is again irrational number. And if we divide under 12 by under 3, that is under 4, which is equal to 2, which is again irrational number. So there are the so many cases when the irrational number, it may be some difference multiplied the quotient, it may be rational and the irrational. So I think if you take other examples under root 3, under root 4, under root 3, under root 5, under root 7, you can also explain by the same method that under root 3 and under root 5, they are all the irrational numbers. Okay, thanks very much.